SQL Slammer. The worm that ate the Internet. Introduction. Name: SQL Slammer. Exploited vulnerability: unauthenticated remote. Compromise in SQL Server 2000. Severity: critical, very high risk. Category: remote buffer overflow vulnerability. The initial infection of the SQL Slammer worm, known as the worm that ate the Internet, was a DOS attack that exploited a buffer overflow bug in Microsoft's SQL Server. Vulnerability. Microsoft's database engine MSD 2000 exhibits two buffer overflow vulnerabilities that can be exploited by a remote attacker without even having to authenticate to the server. What further worsens these issues is that the attack is channeled over User Datagram Protocol, UDP. Vulnerability. SQL Slammer sends a 376-byte long UDP packet to port 1434 using random targets at a very high rate. Vulnerable systems will immediately start sending identical 376-byte packets once they are infected. Vulnerability. The worm sends traffic to random IP addresses, including multicast IPs, causing a denial of service, DOS, on the target network. Single infected machines have reported traffic in excess of 50 megabits per second after being infected. At its peak, it doubled in size every 8.5 seconds. This is why it was able to infect 250,000 plus hosts within 30 minutes. SQL Slammer packet. Description of vulnerability code: obtaining the remote shell. David Litchfield originally discovered this vulnerability, and his source code. The source code will compromise the SQL Server MSD 2000 server and provides a remote shell to any system you wish. The worm was based on proof of concept code demonstrated at the Black Hat briefings by David Litchfield, who had initially discovered the buffer overflow vulnerability that the worm exploited. It is a small piece of code that does little other than generate random IP addresses and send itself out to those addresses. If a selected address happens to belong to a host that is running an unpatched copy of Microsoft SQL Server Resolution Service listening on UDP port 1434, the host immediately becomes infective and begins spreading the Internet with more copies of the worm program. Home PCs are generally not vulnerable to this worm unless they have Microsoft SQL Server Data Engine installed. The worm is so small that it does not contain code to write itself to disk, so it only stays in memory, and it is easy to remove. The worm was made possible by a software security vulnerability in SQL Server first reported by Microsoft on July 24, 2002. A patch had been available from Microsoft for 6 months prior to the worm's launch, but many installations had not been patched, including many at Microsoft. The worm began to be noticed early on January 25, 2003 as it slowed down systems worldwide. The slowdown was caused by the collapse of numerous routers under the burden of extremely high traffic from infected servers. Normally, when traffic is too high for routers to handle, the routers are supposed to delay or temporarily stop network traffic. Instead, some routers crashed and the neighbor routers would notice that these routers had stopped and should not be contacted removed from the routing table. Routers started sending notices to this effect to other routers they knew about. The flood of routing table update notices caused some additional routers to fail, compounding the problem. Eventually the crashed routers' maintainers restarted them, causing them to announce their status, leading to another wave of routing table updates. Soon a significant portion of internet bandwidth was consumed by routers communicating with each other to update their routing tables, and ordinary data traffic slowed down or in some cases stopped altogether. Because the SQL Slammer worm was so small in size, sometimes it was able to get through when legitimate traffic was not. Once this packet is received on the target machine, the buffer overflow occurs and the machine begins sending out the same packet to other IP addresses in a random fashion. When it was released on the weekend of January 25, 2003, it disrupted the Internet. Ironically, a patch for this vulnerability had been released 6 months earlier. The infected servers did not have the updated patch applied. This was a wake-up call for many organizations to implement a security policy requiring that updates and patches be applied in a timely fashion. How to protect against the SQL Slammer worm. Back in year 2003, the UDP port 1434 is only used for SQL Server discovery, and all attempts to access it should be blocked at either the border router and/or firewall. Internal access to the SQL Server or MSD application should also be minimized. For those individuals needing explicit Internet access for their applications, the use of IPsec filtering is recommended, which is available on all Windows operating systems from 2000 on. An example of how to set this up follows. 1. ASUS local security policy of the machine. 2. Name the policy and provide any comments the user deems necessary. When finished, click Next to continue. 3. The next window asks whether or not to activate the default response, Kerberos authentication, rule. Since it was to create a rule to block traffic, leave this box unchecked and click Next. 4. The next window shows a completed rule file. Leave the Edit Properties box checked and click Finish and the following window appears. 5. The next slide asks whether or not to create an IPsec tunnel. This would be appropriate for external Internet connections, that is VPN, since this rule was created to block traffic. Leave it as default. This rule does not specify an tunnel and then click Next. 6. The next window asks what type of network connection this rule was for. Since it is to block all network traffic, leave the default checked and click Next. 7. The next window allows to add multiple authentication methods. Leave the default box checked and click Next. 8. Next, a window which lists all filters would be displayed. Since a new filter was created, click Add to continue. 9. Finally, it will arrive at the screen which will allow to create the filters to block all incoming and outgoing UDP port 1434 traffic for exploit.mem and homenet.local, which is located at IP address 192.168.1.106. Next, the rule creation has to be completed using the Rules wizard. 10. Once clicking Close, the previous window will appear. Need to make sure that the new rule has been created and is highlighted. Then click Next to continue on to the next window, which will demand what to do with the rule that has been just created. Since the goal is to block all incoming and outgoing traffic, leave the default block highlighted and click Next and then Finish after creating rules. 11. Now it would bring back to the original window, which shows the new policy that has been created. More policies can be added, but since the goal was to block UDC port 1431 traffic only, click Close to finish. Propagation. Propagation mechanism. After gaining access to a device, the worm replicates itself and locates new targets. The worm then initializes a propagation routine that generates random IP addresses, and sends the attack packet to each system on the SQL Resolution Service default UDP port 1434. How to prevent future exploitations. Patching should be the first line of defense against this attack. While this procedure shows how you can create a single rule on a domain controller, this method also applies to creating standalone rules on client machines. In that case, you would use Start, Control Panel, Administrative Tools, Local Security Policy path on the client machine itself to create rules for that specific machine. Recommendations. These recommendations are more generic in nature, but serve as a benchmark to help prevent any and all future exploits. 1. A computer usually has a function, whether it to be as a home computer running simple office applications, a workstation running complex computer programs, a web server or any kind. Before one hooks up a computer, one should define its function and the services necessary to perform that function. 2. Use of the netstat and command on a Windows or Unix machine will let you know what ports are open on your machine. For example, POP3 runs on TCP port 110. If your machine is not running a POP server, this port should not be open. 3. Use of filtering. IPsec filters in Windows TCP wrappers on Unix can help further shield the machine from attack, as well as contain the attack once a machine has been exploited. 4. Use ingress, egress filtering at firewall and/or border router to only allow access to the Internet those ports necessary on that machine for it to perform its function. 5. Finally, patch those services with direct connections to the Internet, that at DNS, SMTP mail, POP/IMAP, FTP, SSH, HTTP, web browsers. Thank you, SQL Slammer.